Hello there, I'm Sir Fansi, and I would like to show you how I made a 3D Pac-Man. So let's first have a look at the gameplay. So it's basically, well, you should have to play it. Let's start. It's in 5.1 Unreal. As you can see, we have just like move around. We are on some sort of a square. And the premise was kind of like thinking what would happen if we actually look at behind all the labyrinths inside the Pac-Man. So that's what I made. It's labyrinths inside the labyrinths with a bunch of ghosts that can eat you and kill you, as you can see. And as you have probably very clearly seen here, when we go onto the edge of the cube, it's just gonna rotate and keep on moving. So, and it happens, and wherever you go, on whichever side, it's just gonna keep on endlessly going, and your goal here is to collect all the coins, which you can see in the right. It tells you how many points are remaining, how many have collected, etc, etc. And then you have these ghosts that are trying to kill you. Yeah, everyone is probably familiar with the premise of a Pac-Man. Alright, so before we get into how this works and how this whole system is set up, so because that's what this video is going to be about, just basically explaining how I set up things, so you can go in comments and tell me how it's all wrong, because we're on the YouTube. I would like to say, not just claim, but say that the whole project is open sourced. It's part of my, let's say, challenge, personal project, where I'm making a new open source project every week, and this is a second one I made, so it's available. I'm gonna leave you a link in the description. You can dive into it, make with it whatever you want. It's under MIT license, so you can use it even for commercial projects. And would love to see someone expand on it, or maybe a group of people expand on it. Like, feel free to do with it whatever you want. Okay, I'm gonna leave that in here. And for now, let's just look at a little bit how it works. So of course we have our Pac-Man. That's our strat. Of course, we have here a Pac-Man, that's our base. And what's important is that I have decided not to actually connect a Pac-Man as a player pawn. I thought about it, but I decided it's gonna be just easier to have here a player controller as a player pawn. And that's basically just responsible for taking an input. You can press W, S, A, and D, and has direct access to a Pac-Man reference, which is just an actor that I have access to. And I believe it's not even a pawn, it's just a pure actor. If I remember correctly. Hello, there we go. Yep, it's just a pure actor. So the only thing that happens on the player pawn perspective, which in this case is just a controller, is we get access to pawn, we play some music, and we change directions. Nothing else. Then we have our Pac-Man. Pac-Man is a little bit more complicated, as we could have guessed. And let's start from the top. So we have here some sort of a game over event that's pretty straightforward. You just start by disabling kick, because vast majority of our logic for movement or for not movement is just handled by kick. So the moment you disable kick, it just stops moving. It's an easy way to do that. Then I get access to all of the ghosts, also disable their kick, so they stop moving, play some sound, and just print on the screen game over in the widget. This is just a HUD I get from me reference. Okay, starting game is almost the same action. We have here a set actor kick for the Pac-Man and enable it. Then everything runs. I also had to set up a little bit more complicated system for activating ghosts. So we can have a look at it, because you don't actually usually know what side of the square you are on. So I set up a function that will basically just do a box trace wherever the Pac-Man is. It's gonna do like a scan around himself on the same on average about the same Z height, and then just activate all the ghosts it finds there and enable it. So that would be for enabling a ghost. Then if we go down here on the begin play, we just add some HUD and save the reference to it. Pretty straightforward, nothing complicated. So before we get into our complicated event kick, let's look at the switch movement directions. So that's the event we are calling from the player controller. So I made here a new enumeration that's gonna switch between up, down, left, right, just to make it easier to switch. When it happens, we first check some sort of a branch that we will get to later. And it's basically just making sure, can I actually go through this direction? Can I actually rotate right now? Because there is some circumstances where we don't want Pac-Man to rotate. And if you can rotate, then I'm simply gonna take a player controller, which is a scene component right here, where which my sphere is attached to, and that sphere component is gonna rotate towards the certain direction. either straight ahead, straight behind him, left or right. Pretty straightforward. So now let's actually get into our complicated setup, and that's our event kick. I commented most of the things, so hopefully even if you don't watch the video or if you just want to explore it yourself, it will make mostly sense just from the how the code works and the comments. So for collecting points, that's very simple, very straightforward. That is just a line trace or sphere trace, a sphere trace happening from in front of the arrow. That's right here for our Pac-Man. And whenever that sees something, it will destroy it. And it's looking for a specific trace channel that's a pickups, and only pickups have that trace channel, so it doesn't just start destroying stuff by themselves. Then it plays sound. Super straightforward. There is definitely a lot of ways how this could have been made a bit more optimized, but I think this is good enough for now. Right. Then we have our can move, and then we have actually movement. So this is the and then we have actual movement. So here we basically take a can move, which is a condition that gets set later. It's the same condition that we are using here for rotate. Oh, actually it's not. It used to be the same condition. I had to change it. But now it's just a can move condition. And we also are checking if the player can move forward. And we check how if the player can move forward very simply with a sphere trace. So there is a sphere trace that's running always in front of the player wherever he is, in front of the Pac-Man, wherever he is. And the moment he in front of him is some sort of a labyrinth, some sort of a wall, and a mesh that's hitting this trace channel, which is labyrinth walls. So all these models are blocking it, the blue ones. Then it's not gonna let him continue. So he will be able to move forward with its forward vector, and only if there is nothing in front of him. Because that's why we have it as false. If it's true, it's not gonna move. So should be fairly simple. That's why we are also setting a rotation when with our player controller, because it will influence and change our forward vector. So it's probably the easiest way how to kind of get the right direction and not mess up vectors too much. Because once you rotate the whole thing, it's then the rotators and rotations, and on rotations and locations tend to get a bit messed up, so it can get a bit confusing. But this is a solution that seems to be working pretty well. All right, now we have a circumstance, what happens, and how to know when Pac-Man leaves cube. It's actually very simple. The moment Pac-Man does not it's actually a very simple system, surprisingly simple, because it took me forever to figure out. But basically we are doing a sphere trace around this body of Pac-Man. It's about the same size approximately as the Pac-Man, and it's always checking every tick whether there is something under him. In this case it's checking for the visibility, which means even our cube under this whole labyrinth is blocking it. And the moment the Pac-Man does not have this hit, he is gonna stop moving. So the moment he gets out here, that means the moment nothing is blocking this visibility, it's gonna continue to code. So we are gonna trigger it once just to make sure that we don't overcharge anything, because it's still running on tick, so we don't want this whole code to execute more than once until we reset it and the whole code is done. So we start by disabling can move and can rotate. I actually don't remember why I separated it into two different variables, but I'm pretty sure I had a good reason for that, but I have no clue why now. Okay, then we send a interface message to gameboard interaction, which should start rotating it. We're gonna get into it in a sec, so let me just first look at this. And that's taking our actor, that means Pac-Man, gets attached to the location where he is and is attached to the cube, so it rotates together with a cube and doesn't mess up rotations too much. Then we wait for half a second, second and a half, detach the actor, set up a new rotation, because we want to make sure that, do we need to make sure? Yeah, I'm pretty sure we do need to set up a correct movement rotation once you move. And yeah, because he moves and he now all of a sudden has to move in a different direction he was moving before. Because for example, if he was moving upwards and he goes onto a cube and that cube rotates like this, so he's now right here, he can't keep on moving forward. He has to move all of a sudden in this direction. So that's why we have to set up a new direction, and we cannot re-enable movement right away because it creates a bunch of bugs when the player can basically just run away from the zone before he finishes this short cinematic when he has to move a little bit into the game board. That we used to. Then we enable movement again. That's why it is separated. We enable movement again because we want him to move. Then after for 0.3 seconds, he will activate all the ghosts, and then he can rotate again because we don't want player to actually control the Pac-Man before he is enough inside the labyrinth. And then we activate it. This is the same function for activating ghosts. Pretty straightforward. And let's look at the square. That's game zone. I called it game zone on game board. It should be game board, but I used it's game zone before. My bad naming on my side. And we start by getting a reference to Pac-Man, which I think is actually redundant, that I don't need it anymore, but whatever. And what I also do is that I take all the pickups on the start of the game and just attach them to the game board. It just makes it simple because I want to make sure that it always rotates together with the game board. And for the actual turn, we take all the ghosts, and not just the ones on the same board because it doesn't really matter, and disable them and make sure they are attached to our board. So we want it to rotate with that, right? Then we pick up a rotation from Pac-Man. We want to know which movement direction the Pac-Man went. Based on that, we set up which rotation should it add on our square movement. And then there is a simple timer that should have been named, but let's ignore it for now. And that's basically every 0.01 second, which should be closer to tick. No, I don't think it's quite close to tick yet. Depends on what tick you are running, of course. Then it's gonna just every 0.01 second add a little bit on our rotation. So you basically see this smooth movement, and it's gonna happen 90 times because we have here a variable that's just counting how much is it adding on how many times has it run, and once it has been more than 90 times, or exactly 90 times in our case, it's gonna stop the timer and reset the variable timer. And that means it's gonna always do exactly 90 degrees. And it's fairly cheap. Could have been done with timeline as well if I wanted to do a little bit more animations, but this was just a simple way to set. All right, and for the last one, let's have a look at our ghosts. Ghosts have actually fairly simple AI. Let's try to see if we can quickly explain it. So we have animating ghosts. If you click on play, you can see them going up and down. This simple animation, which is literally just scaling between 0.15 and 0.25 on loop for timeline. There's nothing complicated about that. Simple animation, but a little bit of movement really helps. Then I am adjusting how fast are the ghosts moving. Always based on the variable. So if you click on the ghost, you can see there's a publicly exposed variable, which is a speed, and on different zones to kind of increase the difficulty on different sides of the square, it has different speed. There's also ghost behavior and whether it should be active on the start, but that's actually active on the start is redundant. It doesn't matter anymore because I'm having their function that just activates all of them. Okay, then for the default ghost behavior, that's just enumeration. We're gonna get into it in a second. And then we get our event kick, which is first checking if the ghost can move forward. That's the exact same system that works with a Pac-Man. Just check if there is a wall in front of him. If it is a wall in front of him, we are gonna find next direction. That's a function we are gonna get into in a sec. And if it's not, then simply add actor world offset speed multiplied by a forward vector, and rotation is set up in the similar way as Pac-Man is. Okay, now if we look at our find next direction, this is basically a simple system, well, relatively simple, that is gonna tell us that it's gonna take trace around all of the remaining ghost directions. So he's gonna look to all the sides between 0, 1, and 3 in our 0, 1, and 2. In this case, there we go. Wait, where are we? Look to side and find next direction. There we go. Left, right, and front. Well, not necessarily left, right, and front. Basically the... Oh no, it is. It's always behind, on the right, and on the left, because we know that the ghost is always walking forward. So it's gonna do line trace towards that towards all those directions. Then it's gonna count them to the array, all those directions with which index it is. Then on the end, it's gonna set variable for our smallest direction, because this is basically just a sorting system for finding the smallest one. It's very straightforward. Like since it's super high, then anything that comes here and it's smaller, it's gonna set as the new smallest, and the next time it runs, it's just gonna make sure that the new smallest is actually smaller. If it's not smaller, it's not gonna set it. Fairly simple. And then we have here then after this is completed, we have our direction that's the closest. I'm gonna maybe just explain it with a bit more example, because this could be a bit difficult to imagine. So let's say that my ghost is right here. He is moving, all doing fine. Wait, he's not moving. There we go. He is moving, moving. There he hit, and he did trace here, here, and right here. So what he's gonna do is to take all of these locations that he hit and calculate their distance relative to the player. And the shortest one relative to the player he's gonna pick as a selected direction, basically, if he is on the closest to player. If he is, that's what he's gonna go with. If he is not, he has a random behavior, because I basically made it a little bit more customized. So we have here 2 different kinds of ghosts. I know there's 4 in Pac-Man, but I lost time. I was out of time, so I made just 2. We have this blue one and a red one. Red one is always following the player, and following here means he will automatically pick a location that's closest to the player whenever he hits the wall, and the blue one is basically just randomly running around. He's gonna always pick a random location. It could have been optimized a bit that the blue one, that this switch has been on the beginning, so I don't need to do this whole computation on him, right? But that's probably a bit beside the point at this right now. All right, so now now when you know how it works, let's actually play it for a bit, and we can try to see if you can now understand much better how this whole system is happening. So as you can see, the ghost now is following me, it's going right after me, and if I'm gonna go right here, he's gonna go to the left. There we go. Now he's gonna go to the right, because this location where he's on right now is actually closer than this location. Now the location on the town was closer, but if I just go around him, he is gonna go right here. The differentiator for is the moment I'm closer to this location where my Pac-Man is right now than to the other location back in here, he is gonna go there. It's fairly simple to evade him, of course, when he is small. Oh, well, take it back. When he is slow like this, it's fairly simple to avoid him. But if you get into one of the more difficult parts, where we have just this board that's basically just full of him, full of the ghost that's following you, it tends to become quite a bit more difficult to run away from them. I'm surprised actually how such a simple system actually makes it work really nicely. The Pac-Man, I looked a little bit into how AI works for actual Pac-Man. That's a little bit more complicated. It's basically the whole game, the whole board is made into squares, and different ghosts aim at different squares. But I did not have really an option to set it up here. I mean, I could have, of course, but I did not do that. I tried something different, and I'm surprised how well it actually works. I'm pleasantly surprised how well it works. Okay, that's about it. I believe that's how most of the system works. As you can see, it's nothing extremely complicated. So hopefully now with explanation you understand how it works, and you can recreate something like that yourself. And again, the whole project is open sourced. You can download it, you can use it, and do with it whatever you want. Make something cool, and it would be cool if you decide to some of your additions submit, and maybe we can make it in some bigger project. We'll see. Right, and that will be about it. I'm on to do more projects, and looking forward to seeing you. Bye.